last measure I want to mention is information ratio. And the information ratio can be using as the active return to active risk. So we mentioned that the active return and active risk in the previous lecture, but now we should to discuss more details about that. So the information ratio, it is the measure the average risk in excess of a benchmark portfolio divided by the standard deviation of this excess return. Standard deviation of this excess return is our active risk. So based on this information, we can have our information ratio, which is equal to Rp minus Rb divided by sigma I. And this sigma I is based on Rp minus Rb. So that's the active return over active risk. And here, the sigma A is called the tracking error. So in the previous lecture, we have learned the tracking error before. So you should know what's the tracking error now. And here, you can also remember it's equal to Ra over sigma A. And remember what's the equation for Sharpe ratio. For Sharpe ratio, it should be Rp minus Rf over the sigma I. So the most difference is Sharpe ratio, they compare with risk-free assets. But for the information ratio, we compare with the benchmark. So this is subscript B denote the benchmark. That's not the risk-free rate. So sometimes people say that Sharpe ratio is one special case for the information ratio. And based on the M square and also the information ratio, definitely they are also the higher, the better the result. And also information ratio and should compare with your benchmark. And M square should compare with the market portfolio. So all these portfolio performance measures, only Jessens alpha could not require to compare with other portfolios. And the rest of the measures, they need to compare with other portfolios. Now let's have a look. I compared the different performance measure together. The first one is trainer ratio and Jessens alpha using systematic risk. So you can consider, think about the trainer ratio, we divide by beta. And Jessens alpha, we using capital assets pricing model, CAPM. Both of them, they assume the unsystematic risk are well diversified. And the Sharpe ratio and M square, they are using the total risk. So we use the standard deviation in our equations. So for Sharpe ratio and M square, we consider both systematic risk and unsystematic risk. And the second conclusion is if it is a well-diversified portfolio, you can use trainer ratio and Jessens alpha. If it's not a well-diversified portfolio, we will use Sharpe ratio and M squares. And the third conclusion is the Sharpe ratio is the slope of the CAL, the capital allocation line. And this is based on the Markowitz portfolio theory. And for the trainer ratio, we are the slope of the SML, the security market line. So it's based on capital assets pricing model, CAPM. So that's the difference between them. And then the last one, Sharpe ratio and trainer ratio produce relative, not absolute, ranking of performance. Okay, finally, we will introduce one example to show you how can you using this portfolio performance measures to analyze your portfolio. And let's have a look. There is a pension fund, and it employs 3 different investment managers, and the manager ABC. and each of whom is responsible for investing in 1/3 of all asset classes, so as the pension fund has a well-diversified portfolio. Information about the manager is given as below, and calculate Sharpe ratio, Treiner ratio, Jessens alpha, M-square, and analyze your result. So how can we, based on the following information, to calculate the different measures? Let's have a look. We use the manager A as an example, show you how to do different measures, and then you can go back home after the class. You can calculate the manager B and C by yourself, and then compare your result by yourself. And let's have a look for manager A. Is real return, the return is 10%, and the total risk is 20%. Beta is 1.1. So the first one, how can we calculate the Sharpe ratio? Sharpe ratio should equal to RP minus RF divided by sigma. So let's have a look. RP is equal to 10% minus RF, which is 3%. And then you divide by 20%. So that's the Sharpe ratio. How can we calculate? The second one is the Treiner ratio. Treiner ratio should equal to RP minus RF divided by beta P. So here we use 10% minus 3% divided by 1.1. It is the Treiner ratio. The next one is Jessens alpha. Jessens alpha is RP minus expected return, which is based on CAPM. So now we need to calculate what's the return based on capital assets pricing model. So based on capital assets pricing model, our manager A, the expected return should equal to 3%. That's RF plus RM. RM is 9% minus 3%. That's the market risk premium, and then you multiply beta. Beta is 1.1. So you can calculate this expected return, and then you use this 10% minus this expected return. You will get the Jessens alpha. And the last one is M-square. For M-square, how can you calculate? You go back to our equation. It should equal to, let's have a look. It should equal to RP minus RF multiply sigma M over sigma P minus RM minus RF. So here, let's go back here. It should be RP, so it's 10%, minus RF, which is 3%, multiply sigma M, which is 19%, multiply 20%. And then you minus RM, which is 9%, minus 3%. You will get our M squares. Okay, so that's the result. I will show you all these different performance measure I calculate for each managers. You can calculate, go back home by yourself. And then you need to do is to compare the Sharpe ratio between these three managers. We find that the manager B, they have a higher Sharpe ratio. And for the Treiner ratio, the portfolio C, manager C is higher. And for the M square, definitely this one is higher. And the last one, the Jessens alpha portfolio C, manager C is much better. So generally, might be manager B and C will outperform than manager A. So in this class, we introduce 5 different portfolio performance measures: trainer ratio, Sharpe ratio, Jesson's alpha, M-square, information ratio, and we compare some of them together. And the last, we introduce the example how can we calculate these measures. So that's all for today's class. The next class, we will introduce some extension for all these measures. That's all. Thank you.